I've been getting a lot of questions lately about the chain rule. A lot of people have been asking me, like, how do we do the chain rule? And, we're getting to the point in class where you really need to kind of understand at least the basics of the chain rule and, be able to consistently apply those principles. So I have decided to make a short video here, about, maybe 10-15 minutes, just going over the chain rule. But before I do that, I just want to, let you know, like, in sessions, I don't always have time between answering questions and doing other topics to completely cover every single topic as in depth as I'd like to. So I can't really give you specifics for every scenario. The important part of the chain rule, though, is that we have an inside and outside function. Dialing back a second, I'd like to point out that there are some great resources out there for learning this stuff because so many people have to go through learning this stuff. The best one that I've noticed is Khan Academy. For those of you who don't know, it's just Khan, so khanacademy.com. This guy does a great job of detailing like how to go through every problem in the chain rule. He does a great job in explaining it in layman's terms and just make it easy. I'm not exactly sure if he uses U subs or not. Like I do, and like most of my friends do, but yeah, so that's a great resource. I would definitely check that out if you're struggling with that, with the chain rule, and any other topic really. He has everything on Calc 1, just go to his Calc 1 page, he has everything you could possibly want for this class. So if I'm not doing a good enough job, your TA, your teacher, if you're not it's just not clicking for you, check out those videos. They're only 10 minutes long, and that's really how I learned Calc, in all honesty. So, going back, I have a couple examples for you, so we're going to start out with a basic one. So we have x plus 4 to the quantity to the third plus 2. So, hopefully I'm going to check to see how high you can see this, because I'm not exactly sure on this video here how high you can see. Okay, you can see that. Okay, cool. So yeah, we have x plus 4 cubed plus 2. So this is going to be my f of x. So I'm going to find f prime of x now. To do that, I'm going to have to define my u. Notice I know that I have to define the u because I can't just take the straight power rule of this because we don't have just x to the third. Notice we cannot distribute this exponent through. I cannot make it x to the third plus 4 to the third. That's not true. That's wrong. That's not how we do it. Going forward, with this, we can't just bring the 3 in front. Actually, on this problem, technically we can. So, I'm going to change the problem real quick. I'm going to make it x squared. So notice that change. Just because I want it to be a little different than the same. But, so, every time we see this, we have to define an inside and an outside function. The way I like to do it, and you're going to see Khan do it, is he'll underline a certain part of it, like this. It'll say this is my inside, so I normally call this my u. Then he'll go on top, and he'll take the entire function, and he'll define that as his, I don't know if f of x, g of x, whatever you want to use, just use something to define it. So I normally just say like f1 of x. So all that means that's my outside. So I'm trying to find f prime of x. That's what I'm looking for. So to do that, I'm going to do the chain rule. So if I take my u, I say my u is my inside. So my u, which can equal your g of x, for those of you that like to use it this way, is x squared plus 4. Your du, which is g prime of x, is equal to 2x now, the derivative of this. So I took the derivative of the inside. So this is my inside. Still with me? Cool. It's not too bad, this is a video. Anyway, so continuing. Now I gotta take the derivative of my outside function. To do that, I have to take my outside and move this power. So what I'm going to do is I'm going to do my outside now. So outside. And so my outside is my f1 of x, as I said here. In class, I believe you call it just f of x. That's why I'm using f1, so it's kind of consistent. The reason I don't use f of x is technically I already defined my f of x up here is this whole thing, so I don't want to confuse anybody by doing that. So that's why I'm saying it's a little different, because we're not including this too. Not that it matters in this problem. In other problems it could. So I'm going to say my f of x is just, I'm going to just rewrite this. X squared plus 4 to the third. Still with me? Cool. So, got that far. So now I'm going to take my f1 of x, and I'm going to take the derivative of this. Well, I already said this inside bit was my u up here. It's my g of x. So what I really have is I have u to the third, or g of x to the third. However you want to write it. That's what I really have. Now I'm going to take the derivative of this. So I'm going to get my f prime of x. So to do that, I'm going to take my derivative of this. So I'm going to take d dx, which means derivative of this, which is going to give me, it's going to lead me into, so it's going to give me 3u squared, or 3 times g of x squared. Same thing. It's the exact same thing. So now we got that. Now I can plug this in. Now I'm going to plug my x's back in. So I'm going to get it back in terms of x, because that's what I need right here. So I'm going to get it back in terms of x. So I'm going to sub back in my x's, which I already said up here, for my u, or my g of x, is this. That's this bit. So I'm going to plug that back in for u. So that's x squared plus 4 quantity squared. Am I done? No, because I didn't actually apply the chain rule yet. So now I'm going to apply the chain rule. So I'm going to say 3x squared plus 4 quantity squared times my du. So this is my u prime times, or sorry, back up. This is my f1 of x times f1 of x prime, so that's this, is this, times my du, or my g prime of x. So I'll say g prime of x. So that's this, which is this, is this. So times 2x. That's going to give me 6x x squared plus 4 squared, quantity squared. That's my answer. You're going to ask me a question now. You're going to be like, Nick, why did you ignore the 2? The reason I ignored the 2 up here was because I know that that's going to go to 0 when I take the derivative. The derivative of 2 is 0, so it just drops out. So my answer, 6x x squared plus 4 squared, is my simplest answer. So that's a basic chain rule. You can pause the video if you didn't get that down. I'm going to give you another example now. I'm going to use a natural log. So I'm going to say my f of x is equal to the natural log of 4x to the third plus 8. I want to take the derivative. So I want to find f prime of x again. So, how am I going to do it? Oh, good guess. Chain rule. So I'm going to take the chain rule. So to do that, I find my inside function. My inside. So inside, I think of like it's inside something. So like, you know, like I think of those Russian dolls, and there's one inside of the other. This is something inside something else. So this is a function of x inside this entire function, this outside function. Another way to think about it is, like in a problem like this, is I want to incorporate all of my x's into my u, because otherwise, if I just say included just some of my x's in my u, I would get a substitution where I had u's and x's, and then we're doing Calc 3 differential equation stuff, and we don't want to do that. That's not fun. So we're going to do this. So we're going to say this is my inside. or my g of x, or my u. It doesn't matter how you represent it. And then this whole rest of it is my outside, which is my f1 of x, or your f of x, or however you want to represent it. So yeah. So we're going to take the derivative. So to do that, we need the u and we need our outside and our inside. So the chain rule is essentially saying that we want the derivative. So f prime of x is equal to the derivative f prime. Well, technically, here I'll technically write it. F prime of g of x is equal to f prime of x times g prime of x. That's the technical definition of the chain rule right there. So what this is saying is the outside derivative of the outside times the derivative of the inside. So yeah. I guess another way I could write it is like this. It's kind of hard to write out, but you get the point. Outside, derivative of the outside times derivative of the inside. So this outside, inside. So inside, I'm going to say my u, which I already defined up here, is my 4x to the third plus 8. My du then is 12x squared. That's my inside. Got that done. Boom. Now I need the outside, so outside. The outside is going to be my f1 of x, which is my natural log of 4x to the third plus 8. In this case, it happens to be our entire function. Now we need to sub in for u, though. So what I now need to do is I need to sub in for u. So I found my u, so my f of u is equal to natural log of u. I use this to this. You can think of how you pick your u also like this, because I realized that the derivative of the natural log of x is just 1 over x. Similarly, the derivative of the natural log of u is 1 over u. So it's the same thing. That's another way you could look at how I picked my inside function for this natural log problem. So I got that. Now you take the derivative of this, like I just said. So my f prime of u is going to equal 1 over u. So my f1 of x prime is going to equal 1 over 12x squared. I'm sorry, not 12x squared, that's my du. My 1 over 4x to the third plus 8. And you're saying, Nick, oh, we're done, this is our answer. It's not. We have to multiply by our du. That's the whole part of the chain rule. So we're going to take this, and we're going to go a step further by multiplying it by this, which is the chain rule. So 1 over 4x to the third plus 8 times my du, which is 12x squared. We can combine those, and so 12x squared over 4x to the third plus 8. I can pull out 4 out, so we end up going back over here with 3x squared over x to the third plus 2. I pull a 4 out, see? I pulled a 4 out from here to here. That's how I got that. And then this is my final answer. So my f prime of x is equal to 3x squared over x to the third plus 2. And we're done. Not too bad, not too bad. The last type of problem I'd like to share with you real quick is an E problem. So E's to some people are scary, but E is really, if you put it in your calculator, E is equal to like 2.74 or something. I don't know exactly what it is, but that's what E is equal to. So we're gonna go 4. So I'm going to write my function a little higher. So f of x is equal to 4e to the 8x squared plus 3. That's my function. I want to take the derivative. I want to find f prime of x. Pretty straightforward. So e's to me are easy because we can see in the exponent here, that's just going to be my u, my inside, because what this is, the exponent here is going to incorporate all the x's. We want to take the entire exponent and make it my inside, because if we don't, we would get e to the u plus 3. And then we would be in the same boat. I don't know if you can see that. E to the u plus 3. And then we'd be in the same boat we were just in. So we want to incorporate all of it. So we're going to make this entire thing my u, or your g of x if you like. The only difference between g of x and u, guys, is just notation. So when they sub in, when they do your problems and they sub in for g of x, they just skip like the substitution part. The reason I consistently recommend that you do the substitution part is because, one, we're going to have to do it later in the class when we come to integrals. So if you don't understand it now, you're not going to understand it then. So you might as well learn it now, and it makes these problems a heck of a lot easier. And then two, if you ever do any other type of math class, calculus-based at least, or differential equations, or linear algebra, you're going to have to understand substitutions, or any type of coding. Like, substitutions are key. So it plays a major role in my mind, and that's why I do it that way. I was also always taught this way, so I also think it's pretty easy to set up. So we define my u, so I'm going to rewrite this 4e to the u. I rewrote it. I just wrote it in terms of u. So I just said u, I said over here, I said u is equal to 8x squared plus 3. So that's how I'm able to substitute it in, because this is equal to this is equal to this. These are equal. But the same thing, because I defined it over here. I'm going to take my derivative of the u, so 16x. Now I got this. This isn't the derivative yet. Now I'm going to take the derivative of this. So, take the derivative of this, it becomes what? Just 4e to the u. Pretty simple. So this is my f of u, and this is my f prime of u. Pretty simple. Same thing. Now I got this and this. I got all the pieces I need. My derivative of my outside. So this is my outside, and this is my inside. So now all I do is combine them, mush them together. So 4e to the u times du. So 4e to the 8x squared plus 3 times du, which is, my du is right here. So that's 16x. 16x. Du here. E to the u right here, is defined here. Now we can combine them, and we end up with 64x e to the 8x squared plus 3. And this equals my f prime of x. That's my answer. I'm done. It's not too bad, not too bad. I could take the second derivative of this. So the second derivative, the way we take the second derivative is just the same as we take the first. So now we take the derivative of the derivative. So if I want to take the second derivative of this, I would take the derivative of this. You notice we have a product rule here because we have a separate function from this function. There are two separate functions. So we have to perform the product rule. I'm not going to actually do the second derivative. You can on your own time. But yeah, that's how you do it. You can always check your answer by using Mathway or Symbolab, as I've told some of you. Wolfram Alpha is great. So all three of those work out really well. If you're still having trouble with this, I would definitely take a look at Khan Academy. They got some really helpful material out there that can really do a great job teaching this stuff. For your homework, there's one question on there I just did with a group that was very challenging with maxes and mins. For that one, if you conceptually understand it, I would honestly just plug it into your Mathway because it's a little too hard. I don't remember what number it was. I want to say 7 or 8. It's a business one, but I would not honestly waste your time on it. It took us about 25 minutes just for that one problem. So another thing to note is for your homework, when we're doing concavity, it's the same thing as the relative maxes and mins. It's just with the second derivative. So we take the second derivative, find the critical points otherwise known as inflection points for the second derivative. Then we plug it into the number line. We'll have our number line, and you'll have inflection points. And then you'll plug these numbers. So you say it's like, I don't know, 4 and 2. You'll find like 1 and 5 and like, or sorry, like, I don't know, this will be like 1.5 and like 0. And you plug these numbers into your second derivative for your inflection point. If it's positive, you write positive. Negative, you write negative. And then positive is concave up. So concave up. Negative means concave down. Your interval then would be, for this one, it'd be from 2 to 4, you're concave down. And then from negative infinity to 2, you're concave up. And then whatever this is. Hope this helps a little bit with the chain rule, clear up some questions. Of course, if you have questions, email me. I probably won't respond over spring break, so I'm gonna be camping. I'm not gonna have like access to internet, but I will get back to you as soon as I can. I hope you guys have a great spring break.